Hey everyone, I hope everyone is well. It's Friday, which is nice. I know Tuesday of next week is supposed to be, I think they call it a wellness day. So just letting you know, I mean, we don't have class, we don't meet, this class doesn't meet that day. As far as I know, I'm able to have office hours and I expect to have office hours that day. I'll just let everyone know if that doesn't happen. See, I posted new homework and the quiz. The second homework will be available today at noon, and the next quiz, the second quiz, will be available tomorrow. I did post this in an announcement already, just letting you know. I know this first test is coming up. I expect it to be just on chapters 1 and 2, what I covered. I mean, I'm hoping to start chapter 3. If not today, then definitely Monday. Although I think I'll start it today though, but we'll see. Was I going to say? Oh, with the emails also, I emailed, the first email had the correct, that is, notes, the correct notes. The second email, unfortunately, I sent to this class by mistake, the second email that had notes for my Math 104 class. So again, I'm sorry if that caused any confusion. Okay, I did post some videos on YouTube again, and notes on Blackboard, just, as I said I would in the syllabus. All right, are there any questions at all? Yes. Yeah.
Are the tests cumulative?
No, they'll be based on what I say. No, they're not cumulative. No, the final is, but not the exams.
Okay.
Good question. Any other questions? Okay. So let's get started. So again, what I'm hoping to do today is to finish rates, and I think it'd be good if we did some word problems. Not too many, but a few. Well, it's good. So they're good to do. So let me get this one going. All right. Let me see this one. Yeah. Okay. What the? Again, if you can't see the notes, just let me know. I know Blackboard can be strange sometimes. So, although it could be my fault. Anyway, so this is the first word problem. So what we have here, this is actually from the textbook. We have 4 3-megawatt wind turbines. And it turns out they can supply enough electricity to power 3,000 homes. We want to know how many of these turbines would be required to power 55,000 homes. Okay. Now, again, this is a problem based on rates. So kind of like with the conversion problems we saw earlier, basically we're going to get ratios. We're going to get one ratio having only known information from the word problem. Another ratio will have something unknown in it, and then we'll make a proportion and solve. And really, you'll see that the hardest part about these is setting up. Once you set up that proportion, the rest is just like what we did before. Cross multiplying and then algebra. So we know that 4 of these turbines can power 3,000 homes, right? Well, what they're really saying is for every 4 turbines, 3,000 homes can be powered with electricity. Hence, we have one ratio. We have a ratio, I should say. I know, again, there is a difference between a rate and a ratio, but a rate is a type of ratio. So let's stick with ratios for now. We have 4 of these megawatt turbines per 3,000 homes. So that's one ratio. Okay, so that's good. But we need another one, don't we? Well, we want to know how many of these turbines are needed to power 55,000 homes. So we can get another ratio from that, can't we? Namely, if we let X be how many of these turbines are needed to power 55,000 homes, so the number of these turbines needed to power 55,000 homes, then the other ratio is this. X, where X is how many of these 3 megawatt wind turbines over 55,000 homes. So we have this ratio. We have this ratio, excuse me, having the known information. This one has some known information, but there's something unknown in there. Namely, how many of these megawatt turbines are needed to power 55,000 homes. So what do? Well, both of these ratios have to do with the number of turbines per house, or home, I guess I should say. So they're going to be equal to each other. In other words, we set them equal to each other, right? Because we want to figure out what X is, so let's set them equal to each other. And really, that's the hard part. Once you get this proportion, we're in good shape. Because now it boils down to solving this proportion. Now, is everybody with me so far? Let me ask it this way then. What questions do you have so far? I can't see the chat, so. Okay. So I guess everyone's with me so far. Good. Okay. All right. Okay, so now we have the ratio, we have the proportion, well, we have the ratios, and we made the proportion. Okay? So now we want to solve it. And again, what you want to do first is really you want to eliminate the units. Okay, so, and notice the units we have. Hold on, let me get back to that laser thing. Notice also that we have the same units in corresponding positions, right? On top, we have these turbines, wind turbines. I guess that's what they use from wind to make electricity. On the bottom, right, we have these homes. We have homes. So I guess that's our unit down here. I'm just saying here that you want to make sure the same units are in corresponding position. You know, if one of these ratios was inverted, then, you know, you would have a problem. You would not get the right answer is what I'm saying. Okay. So we can now eliminate these units. So we cancel this one with this one. Yeah.
I came in late, so it's my fault for not being caught up.
Okay.
But what is the 3 after the 4 and like 3 mega wind turbine?
Oh, that's the type of wind turbines we're using.
Oh, so that goes with like the name?
Yeah, that's just part of the unit.
Oh, okay.
That's why I tried to write out the words 3. I probably should have written it here, and I'm sorry I did not do that. Because I know otherwise it would be like 43, which would look like 43. So I wrote the 3 out in words. Hopefully that made it easier. So I hope so.
Yeah, it did, because it like,
Okay.
But thank you.
That's okay. Oh, you're welcome. That's okay. All right. Any other questions? Yeah. So we can cross this off. And now from here, we get this proportion to solve. So that's the proportion we want to solve. Okay, so how do we solve those? Again, what we do is we have to use cross multiplication, right? That's what I'm using here. Okay, you know what? Let me actually draw that. Let me erase this. I want to draw in those cross. So again, right? Cross multiply 4 times 55,000, that's on the left. 3,000 times x. That goes on the right. Right? Okay, so we have this. X is our unknown, and we want to solve for that. And that's, from here, that's how we get to this step. Wait, they can't see that. That's how we get to this step. So from here, we cross multiplied, follow these red, supposed to be straight lines. Then we're over here. That's what you get after cross multiplying. I know I didn't actually multiply 4 times 55,000 here. I mean, you could do that. but I didn't do it yet. But anyway, the next step is over here. We divide by 3,000, both sides. Like so. Okay. And what do we get? Well, we get x on the right side. This should not be, let me fix that. I got there, when I was going through my notes, I forgot to erase this. Sorry about that. Okay. So what we do is okay, so we get x on one side. That's actually because the 3,000s cancel. Okay, so this cancels with this. On the left side, well, now over here, when we actually do this product and then quotient, we get 73.33. So shouldn't be round to one decimal place. Thought I took that out. So what we end up getting is 73 megawatt turbines. Yeah. I mean, here, if you did round to one decimal place, I would still mark it correct because round to one decimal place really shouldn't be there. But we get 73 megawatt turbines. So I know word problems can be kind of, yeah?
So if you need 73.33 to power 55,000, don't you technically need 74 to power all 55? Wouldn't 73 not be enough just to answer the question fully?
Good point. Yeah, you're right. That is a good point. That's right. So right, so I guess technically it should be 74. Yeah, thank you. So I guess it should be technically 74 because you're right. 73 technically wouldn't be enough. Okay, that is a good point. So I mean, on a question like this though, if you put 74 or 73, either one would be correct. So, but right, that is technically 74. Thank you. So we have that. But again, the whole point, but again, this was just a problem where we had to get two ratios, right? Set them equal to each other. Then we cancel units, I guess, cross multiply. And then we get our answer. Right. So yeah, it is 73.33. I had that thought yesterday that it should be 74, but excuse me. Anyway, so right, 73, or I guess technically 74 would be what we really need. So either one of those would be correct, but 74 really is the correct answer. So thank you. Any other questions? Okay, let me just get the